We have two wonderful students who have tried out something in the area of open source, and they would like to share the knowledge with you on open source in Linux kernel. So I would like to invite Bhaktipriya and Shreya to give the talk about this, and they'll be showcasing the demo on open source.
To the diving into open source workshop with the Linux kernel. So as you know, this is going to be hands-on, so I'd encourage you guys to have your laptops on and you can just, proceed along with us. And because we'll be doing all this in Ubuntu, we are just setting up things so that I can actually mirror my terminal here so that, you guys can easily follow and we can have a live demo session. So good morning, everyone. I'm Bhaktipriya Sridhar, and again, welcome again to the Diving into Open Source workshop. Can I have a show of hands? How many of you know about open source? Awesome. And how many of you have already contributed to open source in some way? Okay, awesome, great. And how many of you have heard about the Linux kernel? Awesome. And you guys use it? Or any Windows or Mac fans out here? How many use Linux? Okay, great. So yeah, that makes sense because you are already here in the room. So great. So the first thing, who are we here? I'm Bhaktipriya Sridhar. I worked with the Linux Foundation, basically the Linux kernel, as an outreach intern. And I worked on the work queue interfaces of the Linux kernel, which is a ubiquitous API used throughout the Linux kernel. And I'm also a student at IIIT Hyderabad. And I'd like to introduce my colleague, Shraddha.
Hi, I'm Shraddha Barke from BITS Pilani Goa campus. I'm an electronics student, but I'm interested in computer science, and I was also an outreach intern with Linux kernel. I worked on the staging drivers with Greg Hartman, and I would like to ask my friend to tell you more about open source, and then we'll have a demo about sending a first patch to the Linux kernel.
Yes. So all set?
Oh,
let's get going.
The cloning thing.
So the first thing I want you to know is, what is open source exactly? Is it just a buzzword or is there more to it? So let's find out. So open source is basically any technology or any software whose code is publicly made available. Why is it made publicly available? So that it's open for modifications and enhancements, so that more people come in, there are more eyes on your project, and it becomes better and better. So that's the idea of open source. And now if you have talked about open source, where do you find open source? So open source is everywhere, from the mobile devices that you use, Android smartphones, for example, the operating systems that you use, for example, Linux, and even the mailing clients, the Firefox browsers, Chrome browsers, it's everywhere. You won't know, but it's everywhere, it's all around you. It has a ubiquitous presence. Okay, now we have seen what is open source, where all we can find open source, because it's everywhere. What are the advantages of open source then? What's in it for me? So, next time you're coding a project, and if you want to have a significant impact of your project on this planet, make sure that that project is open source. Why is that so? There are plenty of advantages for a project to be open source. One thing is flexibility, because more and more people will find better uses of your project, and your project will become more flexible. And second thing is better security. If there are more eyes on your project, people will report about bugs, security fixes, and then you'll have better ways of having a better quality product in your hand. And it's easy to customize, because various people have different thoughts about using your product. So the moment you make it open source, people will find newer ways of using your project, and that will make it easier to customize for the people around you. Lower cost, effectively, if more people are using now, you can cut down on your costs. And definitely secure again. And what's in it for a developer? We saw what's in it for a project, but as a developer, what are your advantages? Basically, you get valuable experience working on software that is massive in its size. You're collaborating with billions of people around the planet, and you'll be gaining extremely valuable experience at the end of this. You'll also learn new skills like communicating, learning new languages, technologies, etc. You'll meet awesome people. Well, that's my favorite part. I got to work with some of the best minds of the open source technology who have built and shaped the internet and technology as we see it. So yes, you get to meet awesome people. And lastly, you get to develop and hone your skills that you already know. So these are the advantages as a developer. Fine. Now I hope I've convinced you why you need to do open source, both as a developer and a product manager. So now how do you get started? How do you do the open source contribution? So you can do it in 2 simple steps, looking at it from a developer perspective. First is choosing an organization, and second thing is obviously contributing to it. Fine. So how do I choose an organization? There are plenty of open source projects around, like I just mentioned. Which one is the right fit for you? So well, we can still break this down, and we can say it boils down to 3 things: your skills, your interests, and your roles. So skills, basically play by your strengths. What are you good at? Are you good at Java? Are you good at C? Do you like Python? Go by the languages. Filter the orgs based on the languages. Or probably your interests. That would be the second way of looking at orgs. Do you like to work, are you a big fan of IDEs? Are you a big fan of browsers? Or are you a big fan of operating systems? Would you like to do it that way? The popular technologies that you do every day and you want to be a part of it, is that your motive? Sure, go ahead. Or probably you're a biology major or a computer vision scientist and you just want to focus on your field. There are options out there for math majors, for bio majors. So everybody is welcome in open source. And if you like developing games, Pygame is my favorite. So you should definitely check that out. It's very welcoming, open source. Or if you believe in causes, for example, the humanitarian causes like OpenMRS, which is doing some extremely good work in medical recording system, and it has saved millions of lives in Africa, probably you might want to become a part of such organizations. So these are some of the methods that you could probably look into while selecting an organization. Great. So now you might be wondering that, is it in me? Do I really can contribute to open source? Am I good enough? Well, basically you can have a look at it in the roles perspective, which could go as your third point of choosing an organization. Open source is very welcoming. You just don't have to be a coder out there to contribute to an open source organization. There are plenty of options available. You can possibly add new features. You can do testing, not have to code necessarily, but do testing of their software. You could write examples for the APIs that are already out there, or you could submit bug fixes. That's extremely cool. And there are some non-technical jobs also, like marketing, journalism in open source, which is very popular, documentation, licensing and legal, even community building for that matter. Because these are million-dollar industries that have their code out there, and still they make money out of it. So basically, community building is also very essential in open source. That is also one possible career opportunity or role that you want to look into before you select an organization. Great. So now you've chosen an organization. How do you begin contributing to the organization? What's the contribution process like? So there are 4 steps to this. First thing is set up your tools. Know your organization. What do they use? If it is a Linux kernel, you need C. If it is a Python foundation, you need Python. And if it is a Mozilla Firefox, then you need their source code ready and the dependencies. So basically get your tool set up, the version tracker that they use, etc. Then begin communicating, express your interest, be active on the IRC channels, mail people, tell them that you are interested and these are your interests, this is what you know. And then next thing is target the low-hanging fruits. Now typically every organization has their own way of defining their low-hanging fruits. For example, Genome has low-hanging fruit as a marker for all their issues. Similarly, if your organization is in GitHub, what you should look at is easy bugs. They are tagged as easy and you should try aiming for those first. And similarly, in Linux kernel, we have the checkpatch errors, which are basically for the newcomers. So every organization wants newcomers like you to be there, and they have created customized, easy, low-hanging fruits for you so that you can go there, grab them, and be a contributor for that organization. So target on the low-hanging fruits. And finally, once you have a couple of low-hanging fruits in your hand, then probably you can write to people and ask them for more responsibility in the form of major projects. That's how you contribute. Great. So these are some major open source projects and the typical way of defining their own low-hanging fruits. These are all hyperlinks, so you can go back, check again our slides, and then you can possibly go back and contribute to them. And yeah, and is that it? Like just contributing couple of patches and you're done, you call yourself an open source contributor, is that it? No, there's more to it. You can actually unzip your career from open source. How do we do that? There are a lot of structured programs that await you. Like for example, Outreachy that we were a part of. There's Google Summer of Code, and there's Rails Summer of Code, especially for women. Now Outreachy is especially for women again. So you can target these. These are again a couple of other structured programs that can get you involved. And there are some more which are also like Open Daylight, Learn IT Girl, again typically for women. So you can be a part of these and expand your networks and expand your learning using these. And now it's over to Shraddha for the live demo for submitting your first patch to the world's biggest open source project, the Linux.
Thank you, Bhakti Priya, for the awesome introduction on open source. So now we would be going from a generic perspective of open source to a specific project, and that project is also the largest open source project currently, and that is Linux Kernel. So I personally love Linux because when I first started contributing to Linux, I had just learned C programming, and it was really helpful because everyone on the mailing list was supportive, but most probably...
Yeah, it's a very heavy code, like we told you, it's the world's biggest open source project. So you might start cloning into the Git kernel. Maybe by the end of the demo, you might have the kernel on your laptops. But you can always go back and check out the first patch tutorial. So feel free to clone the kernel.
I'll be showing you how to set up all your tools, what all you should install, and then one lucky person from the audience will be getting a patch. We won't be sending the patch to the actual maintainers, so we'll just ask one of you for your email address and send it to you guys. Okay, so let's get started. So we all know that Linux is written in C and C language. So we need compilers like GCC. We need we need Mutt, which is the email client for sending the patches, and some other editors like Vim or Emacs, whichever is your preferred editor. Now I have all the tools installed on my laptop. So yes. Now we'll be setting up the Git configuration. Git is a version control system which is used by developers of mostly all the open source projects to collaborate on their patches and yes.
How many of you have used Git before? Great.
Oh, awesome.
Okay, and quick question. How many of you like Vim out of Vim and Emacs? It's a heated debate. Okay, great. And how many of you support Emacs? Oh, great. We are doing
Wow.
it in Vim then.
Okay.
Yeah.
Awesome. So this is how you configure your email address. And if you just want to see all your configuration, git config -- list. Now since you all like Vim, we'll be setting Vim as the default editor for Git. Here you could change it to Emacs or Nano or whatever is your preferred editor.
So it's important to set your Git credentials because with Linux, it's very important that your first name and last name actually matches, because when you send a patch, you take the responsibility of either fixing the build or breaking the build. So basically, you need to be very strict with your credentials, and that's why it's very important to get the Git setup right.
Okay. So this, I already have the kernel cloned in my computer.
That's how the kernel looks.
Yes. Okay. So now you need to copy the configuration of your current running kernel. So when you download the source tree from the kernel, download the source code, it does not come with a config file. So you can either use the config file of your current running kernel, which is by this command, or, okay, I won't be pressing it because it will ask for a lot of default options or something. Or you could also use make menu config, which gives you a graphical interface, and you could choose which drivers you want to load as modules, and you could turn off some drivers depending on your purpose for what you're using the kernel. Okay.
And that's how you compile the kernel. That was the most challenging part for me when I started compiling, started with Linux kernel contribution. So there are many phases where you break the build and you fall and you hurt yourself, you hurt the others around you. But then
And
that's how the
this
compiled
takes a
kernel
really
looks.
long time, and this is how it looks like when it's finally compiled.
Yeah, that's a nice kernel, good looking one.
Okay, so now we'll play around with Git a bit. So currently we are at the GHCI first patch branch. Let's check out to the master branch. Now we'll make a new branch, which is git checkout -b first patch. Okay. Now, if you want to see all the commits which have been done before, you just need to press git log, and you can see that Linus has done something. And this is like an entire list date-wise of all the commits which have been made with the commit message and the subject of the commit. Okay. Now we'll set up Vim. So Linux kernel has a particular coding style which all the developers need to adhere to. So for that, these are the configurations which you need to set up in your Vim, like the number of tabs or what number of spaces correspond to one tab and so on. This is file type plugin indent on is for automatic indentation. Then now we can use git send email or mutt or alpine, but mutt is the preferred email client which is used in the entire community. So in this demo, I'll show you the mutt.rc file.
So basically in Linux, what we do is we mail our patches. Probably the video should have made it clear, but since it's not being played. So in Linux, what we do is we don't just put patches anywhere. We mail it to the list of developers who are responsible for the driver, and they take up the fix, and then it goes up, and then finally Linux merges it into the final release of the Linux kernel, and that's how your patch makes it. And that's the idea. And because you are using mailing clients and you're using IDEs, there's a standard which needs to be adhered to, and that's what we are doing exactly.
So in this mutt.rc file, you can set various parameters like your name, your email address, your password. Don't worry, I'm going to change this password after the demo. And where, this is inbox. So this is where all your email is going to go. And there are certain certificates which are needed for mutt. So even that could be included in the mutt.rc file.
You can always go back to our slides and you can just copy paste stuff and you should be good to go.
Okay, so now it has compiled. It took less time because I had already compiled it before. Now we'll just pick one driver from the staging directory and we'll run Checkpatch over it and see. Checkpatch is basically a static analysis tool. So it gives you warnings for if suppose you're not adhering to the coding style of the kernel. So it's supposed to be 80 character line, and if it exceeds that, then Checkpatch would give you a warning for that. And as a beginner, it's advisable that you focus on fixing Checkpatch warnings. So I'll run. Checkpatch can be found in the scripts directory. So I have chosen this specific driver because so I know that there is a Checkpatch warning present in it. You could just change. So if you just press tab here, you will get a list of drivers which you can choose. And and another thing is it's advisable to stick to the staging area if you are a beginner, because it's like staging areas, the development it's an ongoing development. People are not mostly using the drivers which are in staging. The drivers which are out of staging, they are being used by companies. So if you are making a change in that, you should be sure about what you're doing. Otherwise, it's better to stick to staging. Okay. So I'll just choose this driver.
So you can run Checkpatch on any random C file in your Linux kernel. Just pick it, look for style fixes that have a problem, and then you can just go ahead and fix them and get a patch done in the Linux kernel. So that's the way to start.
So it will output all the warnings in this particular file. Yes.
Like you can see, there is unnecessary
so this
parentheses.
alignment should match open parentheses and unnecessary parentheses, warnings like that. So let's pick the first one itself. So we'll fix this particular warning. Okay, that was on line 29. So this is for an unnecessary parenthesis around a pointer assignment. So I'll just make this change. This parenthesis wasn't really needed. Saved. Okay. Now, if you, so this was a very minor change, but if suppose you're making a major change, you need to see what you have done. For that, you use git diff, which will output, so you changed this and you added this. And if you want to see which file exactly you changed, git status. Okay. Now you add this particular file for committing. This has been staged for the commit. Okay. Now, Linux also has a particular way in which you are supposed to write the commit message. So this was driver staging RT-L8-188EU. So you go like staging RT-L8-188EU, and then the subject is whatever change you have done. So here what we did was fix unnecessary parenthesis warning. And then you write the commit message here. Remove unnecessary parenthesis. And the warning was found using Checkpatch. You need to give credit to the tool.
That makes your patch more credible.
Yes. Okay, now you could once again see what change you have made, and yes, so this was the change. Okay, this will, so again you can see git log to see whether your change has been committed, and all this is happening in the current branch, which is first patch. Nothing has been pushed to the master branch yet. So here is your change. Okay. Now we'll make the patch using git format patch. This patch is now ready to be sent. So each directory has, each driver will have a set of maintainers who take care of all the patches which you send to them. So there is a script called getMaintainer.pl which will output all the maintainers you can send this patch to.
Whoever has contributed to this directory will be notified because you made a change in that file. So these are the people who are responsible in coding up that file. So it's important they know the change that you just made. So these are the names, and you have to mail it to them so that it gets accepted.
Okay, now we'll actually mail the patch.
Just one step away. Yep.
So which one of you would like to receive the patch now? Okay,
What's
just
your
tell me your
email
email
address? Sakshi?
You can see it.
Yeah. 7896
96.
@gmail.com.
This is right.
Great. So Sakshi gets the first patch. Go back, submit, and get a contribution at the Linux kernel. So that's it. So we have sent a mail using the command line mailing tool, and the patch should be in your inbox now. Great.
You can check it.
You can check it. And so you can go back to the slide.
Yes. Did you get it?
So right.
Okay. So now that you have submitted, you have learned how to submit the first patch to the kernel. Welcome to Linux, and I hope you would go back and have a look at the slides and then try to submit a patch yourself. You could ask us questions if you have any regarding this. Yes.
So I get that patches like that are pretty easy. I've been contributing myself. But my question to you is, whenever you approach a bigger problem, say you want to tackle something big, so of course the code bases are extremely large. So how do you go about tackling a bug, not a bug or a feature which is extremely big? So instead of just going through the complete code base, how do you start? Like, do you just start coding, or do you first read
No,
the code
first
base?
you have to understand each and every line of the code, what it is doing. And if you don't, you can post on the kernel newbies mailing list. The people there are very responsive. I have actually seen posts like, okay, what does this line of code do? So you could do that. And there is something called lwn.net, which has amazing articles about everything in Linux. So you can read that. There is documentation. And mostly it's like, so if it's an issue, it has been done before in some way or the other, not the exact thing. So you can have a look at that patch, and then in some similar way, maybe you can try to understand this. But the main thing is you should post on the mailing list.
I would actually like to add to that. So in case you're a lazy developer like me, I didn't read all the codes, like all the lines of the code. So Shraddha did it. She's very diligent. She's like one of the most awesome kernel developers. She was my senior in Outreachy. So she has contributed tremendously. But I was not one of those people who would read everything and then do it. So what I used to do was, every structured program or every organization would have issues set up. So they'd be like, hey, you know, this driver has this problem. Why don't you go up and fix it? So I just look at that driver and then read as per need. That's my key. Read as per need. And then probably go ahead. Once you're done fixing that section of the driver, you're good to go. You already have a task solved at your hand, and you can always go back and pick other tasks. So you could also go by the task that the organization has listed. You could do that.
The kernel part, you did a uname and then you did a make.
Right.
So, is there any specific things we need to keep in mind? Because I tried building the kernel once and then it was a very bad thing. I mean, everything broke
been there,
on
done
my
that.
device. Yeah. So, is there anything you need to particularly look in about your the kernel version which your laptop has and the kernel version you're getting from Git or something?
Oh no, not at all. Basically, the config file, all it does is you need to just tell it which section of the source code you need to build. So it's most typical that you use the ones that you already use. The kernel config file that comes in your distro, you can just use that. That's why you have the uname, your username, and your particular customized config file. Use that and you tell them that, hey, these are the drivers that I usually use. Why not just build them up instead of the other millions and millions of other drivers that are present in the kernel code. But if you want, say you're working on something very remote, like an Android driver that you might not typically use on your laptop, then you might want to just add that up to your config file and say, you know what, you need to build this as well. Or perhaps you need to just build Android. So it gives an intuition about what the kernel compiler needs to build and what it does not have to build. That's it. So it's completely up to you. Yeah.
And if you are ever confused, you can just keep the default option, whatever it is. So it will ask you, you want 1, 2, 3, and 1 is the default. So you could just press for 1. And the point of a config file is, so Linux, even with the minimum configuration, it takes a lot of time to compile. So it wants to ask you which all drivers you want to load as modules so that it doesn't take that long. So it only will compile what you actually need. So that's the point of it.
So in the example that you have shown, you are committing to the staging environment of Linux, right? So if we are working on staging, will the changes appear in the production, or it is limited to the playground for developers?
So staging is not a playground. So at one point, the drivers from staging will go into the main code. but it's like it's under heavy development staging. So there are a lot of eyes on it, and even the maintainers are very careful as to what patches they are getting, because the patches are not always trusted. They are mostly from beginners. So yeah, I mean, staging is the way to start. So you don't have to worry that you will break something in the main code.
Okay, thank you.
Heavily tested, yeah, that's what. Staging area is heavily tested. That's what my patches, which I submitted in May, have finally made it to the new release version of kernel. So it goes to a very heavy testing because kernel is very reliable. So you start off with staging, then it goes through massive tests, and then finally it makes it to the release. Yep.
Okay, thank you.
Hi girls, nice presentation. So how do you go and assign yourself to a ticket, because there might be so many tickets, right? And because so many people must be wanting to take that ticket. How are you authorized to that ticket? Also, you send your patches, you mail your patches, you don't actually merge them to the main branch. Is this how it works in every open source project, or is it just in the Linux project? Also, I had another question. When you have really big features, right, there might be many people submitting patches. How are the codes reviewed, and maybe that approach is not accepted? So how do you have that feedback process? Thanks.
Very interesting question. In fact, a lot of them. So yeah, mainly the first thing is when you have a feature, basically your organization lists them down. Like with GitHub repositories, you can go and get assigned to a feature. With Outreachy or a structured program like that one, you can go back and claim. So if there is some task that's been lying idle, you can always go back and claim if someone's really not working on it, or probably grab a new one. That's how you get the tasks. And
you don't always have to worry about claiming it. So with
Yeah.
me, it has happened a lot of times that I made some change, and some other developer in some other country has made some other change in the same file, and our patches are clashing. So that's a common thing. You don't have to worry about it. So you just revert your own patch that the maintainer would do it, and then you make the change again. So this is a common occurrence in kernel, that two people are working on the same thing. Because it's not possible for millions of developers to just collaborate, and like other open source projects are smaller. So it's easier that, okay, fine, this is assigned to this person. Whereas in Linux, it's not the case. And your second question was about?
About feedback. So basically
Yeah.
the kernel developer comes back with the feedback that, you made this mistake, or probably you broke the build, you might want to do it this way, that way. And then you work on that feedback with a new improved patch. So you have various versions of a patch. The highest one I got to was version 10. So yeah, I made mistakes back to back, V1, V2, V3, and then finally the 10th one got accepted. So you will get continuous feedback from your developers. Shraddha, add to that?
Yeah, so there are basically long discussions on the mailing list. You will get lots of feedback. There are like people fighting over, not fighting, discussing over different aspects of how a thing can be implemented. And it leads to good results, as we can see.
Themselves, or there's a admin who creates a branch?
Oh, this is for your remote version. So this is your remote version of the Linux kernel. So you can create as many branches as you want. You can do as many changes as you want, so that you are safe. Your master branch, the actual one that comes up from the cloud, is safe. And you create a first patch branch so that you can try, experiment, break things. It's okay. So what really matters is the patch ultimately, what you email. So that's basically like saying this file has this line changed, and this line was removed, and this token was added. So that matters. Whether it comes from the master branch, first patch branch, doesn't really matter. But yes, what goes on the cloud does matter. Only Linux decides that. So the main branch is decided by him.
When you're making contributions, you mentioned that it's going to go through security testing and lot of other testing. Is there any guidelines that you follow while making this code contribution that it should pass those tests?
Yes, we have a lot of static analysis tools like Checkpatch itself. So when Checkpatch is run typically when you write some nice driver and then you want to send that driver to the Linux kernel, and you just want to see if you have not made any style errors. So you have a lot of style fixes and a lot of static analysis tools that way that help you not only with the coding fixes but even security. Would you like to add to that?
Yeah, so the
Smatch
thing
does that, right?
Yeah, Smatch
Smatch
also does
does
that. There are several static analysis tools, but Checkpatch and Smatch are the most trusted. And regarding the previous question, so you make your remote branch, and then you push it to staging testing. Then there is staging next, which is by the staging maintainers. So there are several such branches. That's what, there was another question about, does it go into production? So the master branch will, like Linus will sign off on the master branch. So that is a very elaborate procedure. It will go through several Git branches before it's finally merged.
So you must be testing your patch before sending it, right?
Right.
So how do you test it? Means because you said that you will just build the driver, so you have to install the driver and then you must be testing it, right?
Right.
So we compile the file which has changed, and if it is not giving any, so if it's not giving errors, we know that at least there are no compilation errors. Logical errors you can't test by tools.
So the maintainers that you mail it to, they will have the hardware. Supposing if you're sending it to an Android driver, he will have that typical Android hardware. He will test it with that and he'll get back to you if it is played safe or not. And then your patch gets accepted. But as far as you are concerned, you can do style fixes, you can do memory leak issues, all that you can fix. But actual going there and testing it on the hardware is done by the maintainers that you mail it to.
Okay, thanks.
So is there any minimal requirements of memory when you're running the kernel code or building it?
Sorry?
Any minimal requirements of the machine when you're running the kernel code?
You need a Linux machine, that's all we ask for.
There is no memory.
There is no memory requirements. Like
So we'll end up with a video about the Linux Foundation, and that's it.
You use Linux every day, whether you know it or not. Over 850,000 Android phones running Linux are activated every single day. Compare that to just 30,000 Windows phones, according to the latest reports. That means 100 Android devices have come online just since you started watching this video. Nearly 700,000 TVs are sold every day, most of which are running Linux. 8 out of 10 financial trades are powered by Linux. 9 out of 10 of the world's supercomputers run Linux. Google, Twitter, Facebook, and Amazon are all powered by Linux. So, how is Linux developed to achieve all of this? Unlike other operating systems, like Windows or iOS, Linux is built collaboratively across companies, geographies, and markets, resulting in the largest collaborative development project in the history of computing. Just since 2005, about 8,000 developers from almost 800 companies have contributed to the Linux kernel. These contributions have resulted in 15 million lines of code, 1.5 million lines written in just the last couple of years. Consider that Homer's epic Iliad poem is a mere 15,000 lines of text. The novel War and Peace, just 560,000 words. But it's not just about the sheer number of lines of code. It's also about how quickly Linux is developed and released. For example, a major new kernel comes out every 2 to 3 months. Compare this to years for competing operating systems. This is made possible by a unique collaborative development process. When submitting code to the Linux kernel, developers break changes into individual units called patches. A patch describes the lines that need to be changed, added, or removed from the source code. Each patch can add a new feature, new support for a device, fix a problem, improve performance, or rework things to be more easily understood. Developers post their patches to the relevant mailing lists, where other developers can reply with feedback. When the patch is close to being release ready, it is accepted by a senior Linux kernel developer, or maintainer, who manages one or more of 100 different sections of the kernel. While this isn't a guarantee that it will go to the main line, it's certainly a good sign. Here it gets an even more extensive evaluation. When the maintainer finishes their review, he or she will sign off on the patch and send it on to Linux creator and Linux Foundation fellow Linus Torvalds, who has the ultimate authority on what is accepted into the next release and what is not. Nearly 10,000 patches go into almost every new release. About 6 patches are applied to the kernel each hour. Linux's rate of development is simply unmatched. Today, Linux is dominating on mobile devices, in the enterprise and web infrastructure, data centers, supercomputing, and more. What's next? Because together, we're ready.
welcome to open source.
So the intent of showing this video was not to show how elaborate the patch process is to discourage you, but to let you know that how many lives you can impact if you contribute to Linux, because it is everywhere.
I apologize for saying them as students. Now I should say them as experts. A huge round of applause for contributing to the Linux and creating the awareness. So a small momentum for both of you.